Hello, today we're going to learn 2.3, which is terminology for system of linear equations. So in this section, we're going to learn some definitions about linear system. So it's kind of introduction. And in the next section, we're going to start to solve those kind of linear system. So first definition, the general n by n linear system is of this form. Let's take a look. So n by n, we can write down. So we have m rows. So a11 x1, a12 x2, a1n, and the right side we say that is b1. Second equation, a21 x1, a22 x2, a2n equals xn actually, bn, and skip the middle rows. The last row, m1 x1, m2 x2, mn xn equals bn. Okay, so this is the general definition for the linear system. Let's take a look at Aij. So here you can see Aij, they are called the system coefficient. Okay, and here Bi, always say just Bj. Okay, they call the system constant. The right side. And those constants may be complex number. And here x1 to xn, those ones, they are unknowns. Okay, and if the bi, the right side of the constant equals, so if all the bi equals 0, then the system is like all the equation, the right side is 0, so we say the system is homogeneous. The system is called homogeneous. Okay, that's the definition, homogeneous. So definitely if bi is not 0, so we say non-homogeneous. So otherwise, it is called non-homogeneous. Let's take a look. I'm going to give you some just an example. Okay, so for example, like this one, negative 3x plus 5i plus 6j equals 1. Negative x. So we know this is a equation. The system has 3 equations, 3 unknowns. So here for the unknown, we write down x, y, z. But in the future, we may also write down x1, x2, x3 as the unknowns. So this is the linear system, 3 by 3 and non-homogeneous, right? So this is non-homogeneous, homogeneous system. Okay, let's take a look at this one. x1 plus x2 equals 0. 5x1 minus 6x2 equals 0. So this is a homogeneous system, 2 by 2, right? 2 by 2 linear system. Okay, so this is the first definition. In the next section, we can use matrix to solve those kind of system. Let's take a look at the solution. So let's see, definition 2. Solution to the system. So here I'm just going to give you a brief definition. So what's the solution? Solution means they have to be ordered scalars like this. Solution look like this way, okay? C1, C2, Cn, and when we plug in those into the linear system, it satisfies the system, okay? So we can satisfy those equations, same thing. Let's take a look at this one. So let's just take a look at 2 by 2. This is a linear system with 2 equations, 2 unknowns. Okay. And then we know how to solve this before, right? We can do substitution method, we can do elimination method. The solution for this one actually is, before we write down like x1 equals 1, x2 equals 2, right? But right now, our solution in this class, for our solution, we are always going to write down this way. Sorry, 1, 2, like this. Okay. Order the pair. So next, we have those questions. Does the system have a solution? Can we always find a solution to the system? If yes, if there's solution, how many solutions? Okay, next question. How to determine the solutions? Let's take a look at this linear system. For example, x plus y equals 5. Here is 2x plus 4y equals -1. Okay, let's take a look at those 2 equations. Actually, they both are linear function, right? If we look at the first one, so this one is y equals -x plus 5. We can draw the graph of the first function. Okay, -x plus 5, something look like that. And we can also solve from here. Let's do 2y. Okay, so y equals -1/2 plus this divided by 2. And for the second one, same thing, y equals -1/2 x minus 1/4. Okay, so you can see from those 2 functions, you can see actually they are parallel because they have the same slope. The both slopes are -1/2, right? So we can say same slope. In the future, you don't have to always solve for y. You just look at those coefficient. Actually, proportional. They are proportional. So you can see the coefficient for x in the first equation is 1, second is 2, so 1/2, and then for the y coefficient is 2/4. They are proportional. So the coefficient for x1, x and y are proportional, so they are parallel. In this case, you can see they never intercept, right? So those 2 equations, they are parallel, never intercept. There's no intercept. That means there's no solution. In this case, no solution. Okay. So sometimes for some linear system, there's no solution. So we want to tell how to just look at the coefficient and see, do we have solution and how many solutions there are. Definition 3. So here just to give you some brief idea, like one example. But in the future, we'll see a lot of more system. Definition 3, matrix of coefficient. Okay, so matrix of a coefficient, you can see the definition. So that means coefficient. So what's that coefficient? Coefficients are Aij, right? So if we pick all the Aij out and we make a matrix, that is called the matrix coefficient. So let's take a look. So the first row, coefficient A11, A12, A1n, A21, A22, A2n, and the last row, AM1, AM2, AMN, and this is called a coefficient matrix. Okay, so you should use capital A. Next, there's another kind of matrix. It's called augmented matrix. Let's see what's that matrix look like. Augmented matrix. So usually we write down that as A pound, okay, and which equals 2. So we just add the coefficient here, which is A, and we add all the B as the last column. So this is called the augmented matrix. Let's write down this one. A11, A12, A1n, and then we add the B1 here. A22, A21, sorry, A22, A2n, B2. Okay. The last row, AM1, AM2, AMN, and BN. So we just need to add one more column to the matrix coefficient of coefficient. We can get the augmented matrix. Now let's take a look at the example, and we are going to write down some matrix coefficient matrix and augmented matrix. So let's see the first example. Write the system of equation with given augmented matrix. That means augmented matrix is given. We want to write out the linear system. Let's take a look. The augmented matrix is given by that one. So 1, 2, 9, negative 1, 1. 2, negative 3, 4, 2, 3. 1, 3, 5, 0, negative 1. So let's take a look at this matrix. Each side, this is augmented matrix. So that means the last column is B, and here is the matrix of coefficient, right? Coefficients. So let's take a look. How many columns in the coefficient matrix? 1, 2, 3, 4. That means we have 4 unknowns. Right? So we can just write down the coefficient, the equations, linear system right now. So let's see. The first one is like 1 times x1, 2x2, 9x3 minus x4, and the right side, which is 1. That's the first equation, right? So for this one system, we have 3 equations. Let's write down the other 2. The next one is 2x1, negative 3x2, 4x3, 2x4, which equals 3. The last one is 5x3, and the plus 0 times x4, so we can just leave 0 there, which is negative 1. So this is the linear system, right? I'm going to give you one exercise. So here, opposite way, I give you the linear system. Want you to write down the coefficient matrix and the augmented matrix, both. So let's see. Here is the first equation. Second equation. Please write down A and A pound. Okay, both. This is pretty easy, right? So let's just write down A. A just means we pick the coefficient out. So which is 1, 2, negative 3 in the first row, because we don't include the B for the matrix coefficient, right? 2, 4, 95, 7, 2, 91. That's all. And for the augmented matrix, it's almost same, but we just add one more column here. So let's just write down the whole thing. Okay, just like this. Next, let's take a look at the linear system. We are going to write the linear system in another way. Let's just take a look at this linear system. Okay, just look at this linear system. We learned actually the product of two matrices, right? So for the left side of the linear system, we look that as the product of this one. So you can take a look. Coefficient matrix and equals to the right side 1, 2, 3. Let's take a look left side. Is that correct? If we do the product of A and we say that is x, okay, x, we make this as column vector, which equals x column vector, right? So if we do the product, you can see we use the first row times this column, so give us 1 times x1, 2x2, then 3x3, and give us the first equation, which equals 1, the product, right? And the second, like the second row times the column vector, give us number 2. Third row in the matrix coefficient times this column give us number 3. So when we do the product, they just give us all the equations. So in the future, for our linear system, we write down this way. And then for the right side coefficient, we write down like b. Okay, so in the future, we will write down our linear system as ax equals b form. So let's see definition 3. That is called the vector equation. Vector equation means if we have linear system like a11 x1 plus here a1n xn equals b1, and here am1 x1 amn xn equals bn. So in the future, this can be written as this form: ax equals b form. Okay, vector. This is called the vector form or vector equation. And what is A? A is the coefficient matrix: a11, a1n, am1, amn. So this is m by n matrix. And what is x? X is the column vector, which is x1, x2, has all the unknowns. And what's the b vector? B vector is the coefficient. No, they are the constant. Okay, column. Made the column vector by using the constant bn. Okay, like this. So let's call the vector equation. So this section is called terminology, right? So before we solve the linear system, we want to just learn some basic idea like how to simplify the system, how to write down the linear system in either way. X is also called the vector of unknowns. And B is called the right-hand side vector. Or you can call that constant vector. So doesn't matter too much. So the set of the solution is we write down this way. Okay, set of solution. Because sometimes in our class we may not just have a unique solution. We may have multiple solutions. So in the future we may have set of solution is write down as this way. So all the x, okay, belongs to Rn. Do you still know how we write down our solution? If it has two unknowns like this one, right? So this belongs to R2 actually. So general, if we have n unknowns, so should belongs to Rn. So the vector, the unknown belongs to Rn, and all the x satisfy this equation. Okay. So in the future, we write down solution set in this way. X satisfy Ax equals b. Now let's take a look at this one. For example, if A is given by this 1, 2, 3, 4, negative 1, 2, 7, 6, 3, and B is given by this 3, 1, negative 5. Please let's write the linear system. Write out the linear system. So this means what? This means 2x1, x2, 3x3 equals 3, right? The first equation. So Ax equals b. Second, 4x1 minus x2, 2x3 equals, second number in b vector, so which is 1. And here negative 5. And the last row, 7x1 plus 6x2 plus 3x3. Okay. Now let's try this exercise. I'm going to give you just like x plus 2y, 3j is j plus 4w. So here we have two equations. Let's write this in this form. Okay, in that form. And please also find what is A, what is B. So let's write down this in vector form. Please try this by yourself. Okay, vector form. So what's the coefficient? 1, 2, 3, 4, 2, 4, negative 3, 5 coefficient. What's the unknowns? Unknown should be x, y, z, w. Actually, this is 2 by 4, so 4 by 1, definitely we can multiply them together, right? And this one equals actually 3, 1. Okay, this is the vector form. And what is B? B is this one. And the coefficient vector, coefficient of matrix is this one. Okay. Similarly, let's see if we have linear system of differential equations. Let's take a look at this one. Let's take a look at this linear system. dx1 dt 3tx1 9x2 6e to the t dx2 dt, which equals 2x1 7x2 3e to the t. Okay, so for this one, let's see, we want to write down this into a linear system. This is system of linear differential equations. Okay, so we have two unknowns, x1, x2, right? We want to write down in this way. So let's see. The left side, we say dx1 dt, dx2 dt. We are going to write down this into a matrix way. And then we write down this as this part as product of, you can see, 3t, 9, 2, negative 7. Is that right? Just the coefficient of x1, x2, coefficient of x1, x2. So give us 2 2 by 2 matrix, and then we can add this as 6e to the t, 3e to the t, like this way. And the left side, we write down this as dx vector. And what is x vector? Because we learned the derivative of a matrix function, we just take the derivative of each element, right? So actually we can look this as, you can see, we can look this as d dt x1, x2. Okay, and that's the derivative of this matrix, and we can also write down this as d x dt. X make this into column vector. So in this case, you can see the vector form for this differential equation system is given by dx dt, which equals ax plus b. Is that right? Okay, let's take a look at another example. Okay, let's rewrite linear system. Given vector information of the system equation, so let's see. Okay, just to write down this. Find the vector formulation for the system of equations. Let's take a look. The linear system is given by this way: x1 prime sin t x2 plus e to the t, and x2 prime, which is 7t x1 t squared x2 for e to the negative t. Okay, we want to write down the vector formulation for this one, vector form. So, firstly, the vector form means what? The left side, x1, x2, derivative, right? And equals to, the vector form is, we need to write down this into matrix way. So x1, x2, what's the coefficient? 3 sin t. And here 7t t squared for the second row, right? And then add a constant. Why is called constant? That's because there's no x1, x2. So they are constant. So e to the t, be careful, the second column, because it's add negative 4 e to the negative t. This is the vector form. And that means x vector is x1, x2. And A matrix is 3 sin t, 7t t squared. And B is e to the t negative 4 e to the negative t. Okay, so in the midterm, we may have similar problem, ask you to write down the vector form. So you can just write down either this way, or you just write down the coefficient A, B. Okay, coefficient matrix A and B, those kind of things. Now let's take a look at this exercise problem. So we have a linear system of differential equation here. 3x2 plus 4t, 6x1 minus 4x2 plus t squared. Let's write down the vector form. Okay, here's the solution. The vector form is x prime equals a x plus b, and what is a? A equals -4, -3, 6, -4, and what is b, which is 4t t squared, and what is x? x1, x2. Okay, or you can write down just like this: x1, x2 derivative, which is ax plus b. B should be 40 t squared. Okay, we can stop here for this section.